morning to one and all. I extend hearty welcome to all the participants from various colleges and industries. I welcome you all this webinar. It's a great privilege to welcome our resource person, Dr. D.P.Rufus, Principal of Apex Polytechnic College, to conduct this webinar. He is a great experienced person. He completing the PG degree in Coronia University and doing PhD. He has a 5 years experience in assistant professor and vice principal in SCAD Engineering College, and now he is working as a principal in Apex Polytechnic College. It's a great pleasure to welcome such an eminent person in this program. Welcome you, sir.
I would like to tell a few words about my college. This college was established in the year of 2006 in the greater vision to reach the unreached by our chairman, Dr. S. Babu. And I have taken charge in this college from the year 2015, and we are doing great things here. And we have a skill development center, and we have a placement center, and we have some CNC programming centers are there, and we are doing many projects here. Our students are doing many projects. They are manufacturing many projects inside the campus, and also we are employ our students in various companies like Lesson and Tubro, L&T Infrastructure, Hitachi, and CRI Pumps, and many more companies. So, doing great things here. We have a well qualified and experienced faculties. Many of them are doing research in polytechnics. You cannot find the faculty members with a PG in our college. All the faculty members are completed their PG program, and many of them are doing research. So we are the #1 polytechnic college in the south zone of Tamil Nadu.
Very good morning, honorable person here. I'm happy to see all of you through this online webinar. I thank all the faculty members who are taking effort to telecast this program, and also thank all the participants from various colleges, universities, and my dear students and my dear colleagues for this online webinar. Let us start this session. I'm sharing my PPT. If you are not okay, if you are not see the PPT, kindly ping me. Now I am presenting my PPT. Okay. Hope you see the PPT. Biogas from the dairy waste. So this biogas is coming under the renewable energy. Renewable energy is nothing but the energy collected from the renewable resources. That means renewable resources are sunlight, wind, water, bio waste, and so on. So there are 5 streams in the renewable energy. Number 1 is wind power. Number 2 is hydropower. Number 3 solar energy. Number 4 geothermal energy. Number 5 bioenergy. Okay. Now you may have a question, what is biogas? The biogas is nothing but it is naturally produced from the decomposition of organic waste by the biological breakdown of the organic matter. What are the bio waste? Food scraps, animal waste, dairy waste, sewage water, and so many other wastes are there. So we are breaking down the organic matter of the biowaste, then we can get the biogas. So now we can move on the raw biogas. What are the things available in the biogas? Number one, 55 to 65 percentage of methane. You can find the 55 to 65 percentage of methane in the raw biogas, and also you can find 30 to 45 percentage of carbon dioxide, and also you can find some traces of hydrogen sulfate and also some traces of fractions of water vapor. So pure methane has calorific value of 9,100 kilocalories per meter cube. So this is the biogas, and now the uses of biogas. So this biogas is used to generate the electricity, and we can use this biogas as a RNG. Then we can use this biogas for the transport sector. If you go to Delhi, you can find the biogas buses, and if you go to Europe countries, you can find the biogas powered vehicles, and we can use the biogas for the cooking purpose. That means domestic gas stoves, we can use the biogas. That means methane. So then we can use this biogas for the portable electricity generators. If you see the PPT, I have shown the generator, and we can use this biogas as a carbon credits to maintain income from CDM payments in some other countries. And also we can compress this biogas and fill the cylinders, and we can issue the cylinders to the industries also for homes. And direct conversion of biogas to the electricity by the fuel cell is also possible. Why this biogas is needed now? The world is meeting energy crisis. Every day energy need is going high, so that this biogas is needed. And also I am furnishing some advantages and some uses of biogas. This biogas reduces the pollution. This biogas reduces the time wastage while collecting firewood, and this biogas reduces the reliance of fossil fuels, lowers fuel import bill, and save the environment, improves the living standards in rural areas, reduces global warming, produces good quality enriched manure to improve soil fertility, effective and convenient way of sanitary disposal of organic waste, improving the hygienic conditions. So if you use the biogas, these are all the advantages. And also we have some disadvantages also. So explosion chances are there, high capital lost, and incorrect handling of liquid sludge causes pollution and requires control and maintenance, and need proper condition, and use as a fuel requires removal of carbon dioxide and hydrogen sulfide. So these are all the disadvantages. So high capital cost is required to establish any type of biogas plants. So in India has installed 12.34 million of small scale biogas plants. Also, India is producing 5,940, that means 5,940 megawatt biomass are connected to the grid, and 994 megawatt off-grid power plants are also there. So total biogas production in India is 2.07 billion meter cube per year. But this is very quite low, because our estimated range is 29 to 48 billion meter cube per year. India can 16,800 megawatt from agro, and 5,000 megawatt from Baggy's cogeneration, and 2,700 megawatt energy from the other resources. India can, but India is only producing 2.0 billion meter cube per year. So let us move on the dairy industry in India. So probably my research area is in dairy waste. So how to collect energy from the dairy waste, so that I'm moving on to the dairy industry in India. If you take in India, dairy market in India reached the value of 10,527 billion in the year of 2019. More than 10 million dairy farmers are there, 96,000 local dairy cooperatives are there, and 170 dairy manufacturers, producers are there. Dairy industry is contributing 6.5 lakh crores to the national economy. Every year, the growth rate is 5%. And also, this dairy industry is contributing 20% to the total agriculture GDP. Dairy industry is contributing more than the paddy and the wheat. Actually, India is the top exporter in the paddy and wheat, but this dairy industry is contributing more than the value of paddy and wheat. An average of 190 million tons of milk production the year 2019 and 20. So, in India, uh, please see the India's GDP overview. In India, agriculture is contributing 17.32 percentage. In total GDP, the agriculture sector is 17.32. In this 17.32, this dairy industry is contributing 26 percentage. So now let us move on to the dairy industry. This dairy industry is producing sour milk, hard, soft cottage cheese, cream, butter, and cream, milk powders, lactose, and ice creams, and many types of dairy products are there. Dairy effluents coming from the industry is having high organic content, like emulsifiers, stabilizers, lactate, acetate, citrate, proteins, and it also having high range of pH value. It is also very dangerous to the environment. If you if you leave the effluent to the soil, definitely the soil will get damaged. So we have to then come to the volumetric load is 1 cubic meter of effluent is coming per ton of processing the milk. See, if you processing the milk for various type of products, 1 cubic meter effluent is coming out per ton. So hence, approximately in India, 6.7 crores tons of dairy waste are coming. In India, 6.7 tons of dairy waste are coming per year. So we can get more electricity, more gas from the dairy waste. So let us move on to the methane production. The conversion of organic materials to the methane is accomplished by the chemotrophic and non-methanogenic and methanogenic microorganisms. The conversion of organic matter to the biogas occurs by following the 4 steps. There are 4 steps are involved. One is hydrolysis, acidogenesis, acetogenesis, and methanogenesis. So I would like to explain few words about the anaerobic digestion. This is the series process. Before the anaerobic digestion, we can go for some pre-treatments also. Why this pre-treatment? Pre-treatment is to solubilize the raw sludge. If you solubilize the raw sludge, we can easily digest the sludge and we can get the methane in a faster way. So anaerobic digestion, there are 4 processes, as I said early. One is hydrolysis and acidogenesis and methanogenesis. So these 4 processes are happening in the anaerobic digestion. There are so many types of digesters also there. So I have furnished some digester types, fixed dome biogas plants. These are the common biogas plant used in all over the world, and floating drum plants are there. Low cost polythene tube digester are there, balloon plants and horizontal plants, earth pit plants, ferrous cement plants are there. So there are so many plants there are so many digesters there. So let us move on to the process, how the methane is coming out from the dairy waste. The first process is the hydrolysis. The hydrolysis steps is to degrade both soluble and non-soluble and insoluble organic material such as lipids, proteins, polysaccharides into soluble organic substance. See, the hydrolysis process are mainly used to dilute or solubilize the wastewater coming from the dairy waste. And second process is acidogenesis. The substance formed during the hydrolysis are further split during the acidogenesis, the second step. Volatile fatty acids, VFA, are generated by the acidogenic bacteria, and as well as NH3CO2 and H2S, hydrogen sulfide, carbon dioxide, and other intermediate compounds are coming. We are removing in this acidogenesis process. And the third step is acetogenesis. That space we are doing higher organic acids and other substances formed by acidogenesis further digested by the acidogens to produce mainly acetic acid and carbon dioxide and hydrogen. Then next to the methanogenesis, finally the last stage. This stage is very important. The methane by 2 groups of methogenic microorganisms. The first group converts acetate into the methane and carbon dioxide, and the second group uses hydrogen as an electron donor and carbon dioxide as a acceptor to produce the methane. These are the 4 steps involved in the anaerobic digester. So see the general features of biogas. This biogas contains 6 to 6.5 kilowatt per hour or meter cube, and some fuel equivalents are there. Explosion limits are there. 6 to 12% biogas exposed in the air if you will burn. So ignition temperature is 650 to 750 degrees Celsius, and its smell is like bad egg. These are the general features of biogas. So, what are the factors affecting the production of biogas? If you go to any type of production, there are some factors, there are some problems, there are some hitches are there. Like that, in this biogas production from the dairy waste also have some hitches, like the quantity and nature of organic matter is very important. Temperature and acidity and alkalinity of substrate, the flow and dilution of material. These are the 4 main factors are affecting the production of biogas. So we need the proper pre-treatment. We need the proper pre-treatment. If you treat the any type of wastewater, waste activated sludge, we need the proper pre-treatment to produce the biogas. If you treat it properly, we can avoid this factor and we can improve the yield of the biogas. So I am furnishing. If you treat the dairy waste, okay, the purpose of the pre-treatment is to remove most of the non-soluble solids physically in order to produce methane. So see the advantages. If you treat the treatment, increment of performance of digestion is high, hasten the decomposition of sludge matter. We can increment of biogas generation, exclusion of pathogens, reduction of specific sludge production, lessening of bulking and foam formation, enhancement in dewatering and settling properties, enhanced degradability of complicated substance and industrial remains, high hasty digestion, and enhanced solid reduction, and elevated residual stability are the advantages while pre-treating the dairy waste water. So there are three types of pre-treatments are there. Number one is physical method, number two is chemical method, number three is biological method. See, in physical method there are four types are there. One is mechanical, thermal, ultrasound, and electrochemical. And most commonly we are using mechanical, thermal, and ultrasound. And chemical method, alkali methods are there, alkali, oxidative methods are there, ozonation is there. If you go to biological method, microbiological methods is there, and enzymatic methods are also there. And also we can pre-treat the sludge by combining two pre-treatment process. We can use physical and chemical, and we use physical and biological, and we can use chemical and biological. So we can use combined process also. So number one, mechanical pre-treatment to enhance the digestion performance, including elevated definite biogas generation. The main reasonable approach is to interrupt microbial cell walls in the waste activated sludge and to allow degradable materials to release outside their cells is an important mechanism in the hydrolysis phase of digestion. See, during this process, we are interrupting the microbial cell. We are breaking the microbial cell by the mechanical pre-treatment. What is the mechanical pre-treatment? There are so many types of there. Number one is thermal pre-treatment. Nothing but we are heating the waste activated sludge. Just we are heating the waste activated, and here there are two types are there. One is high thermal pre-treatment and low thermal treatment. If you heat up to 70 degrees Celsius, this is the low thermal treatment. If you heat the waste activated sludge up to 170 degrees Celsius, that means the high thermal pre-treatment, and the thermal energy employed during the heat pre-treatment disturb the chemical bonds of the cellular wall and the cellular covering, thus releasing the cellular materials into the aqueous portion. சீக்கிரம் கொடுங்க, எடிட் வேற பண்ண வேண்டியிருக்கு. எங்க இருக்கு? இதுல கொடுங்க, என்கிட்ட கொடுங்க, எதை கொடுங்க. எடிட் பண்ணிடுவாங்களா குயிக்கா? கேட்டுருங்கண்ணே, ஃபோன் பண்ணி கேட்டுருங்க. நான் குயிக்கா முடிச்சிடுறேன், ஒரு 1/2 hour முடிச்சிடுறேன். Okay. Now, second one is microwave pre-treatment. The thermal effect is created by the impact of fluctuating electrical field with the bipolar compounds like hydrogen sulfide, proteins, fats, and other complex molecules. What will happen in this microwave pretreatment? It will rupture the hydrogen bonds consequently, and disintegration process is started. The cells are started breaking in this microwave pretreatment, and researchers are reported about 50% of increment in biogas production of microwave pretreated sludge. And chemical pretreatment. In this chemical pretreatment, alkaline pretreatment is there, and we can use alkali agents, NaOH, KOH, and some other alkalis are there. If you add the alkali, if you add the alkaline, what will happen? Rapturing the sludge biomass cell wall is started. The rapturing the sludge biomass cell and the membrane has started. Automatically, this disintegration process is started. So this process is very easy. This process is less cost. It's also help the biogas production. So now come to the ozone pretreatment. It has tough cell lytic action and acts with the polysaccharides and proteins, lipids, and various multifaceted organic mixes to change them into simple one. Here, this ozone in ozone pretreatment, just we are doing the complicated organic mixtures into the simple mixtures. That's all. So if you do the process, automatically the biogas production is increased. Automatically the biogas production is increased. See, in anaerobic digestion, enhanced 45 to 65% of increment of production in biogas. Increment of production in biogas after the ozone pretreatment. So this process is process cost is high, but the results is good. And mechanical method. Come to the mechanical method. Number one is ultrasonic pretreatment. In this ultrasonic pretreatment, it is enhanced to enhance the biodegradability, liquefaction, disintegration of biomass, reduction of solids, and decrements in flux size. Ultrasound, when the passing across the medium, it creates a stress emission that permeates through the particles and produce the gas and vapor bubbles. As a result, cavitation occurs. This elevated shear stress are generated and react on the materials in the medium, which is primarily accountable for sludge disintegration. Sludge started disintegrated. The cells are starting disintegration in this ultrasonic pretreatment. And let us move on to the disperser treatment. Disperse is nothing but just we are allowing the rotator to rotate inside the waste water. This process was usually based on the disintegration of sludge cell walls and cytoplasm into the aqueous portion through the effect of stress ascent, cavitation, instability, impingement, shear pressure, and extended shear got increase of biogas production in dispersion pretreatment. This is like a agitator. And biological method, there are so many biological methods are there. Bacillus lichis are added, and if you add the lichis, it will break the cellular walls automatically. If you break the walls, we can liquefy the waste activity sludge easily. The bacterial pre-treatment experience along with the anaerobic digestion yielded 57 to 53 percentage, 53 to 57 percentage increment of methane in the biogas production. So, see this picture. These are all the these are all the various pre-treatment advantages of various pre-treatment methods. See, many researchers has done the work. I have plotted physical pre-treatment method, competitive pre-treatment method, and chemical and biological pre-treatment method. How much of biogas production has been increased, and how much of COD solubilization has been increased, furnished, and so many researchers has done the work. So I have just plotted for your information. So this biogas production will employ the major role and will give more electricity, more energy, and also will give more employment in future. Thank you. I'm also doing some research work in this area. See, my work is just I'm breaking the extra, just I'm removing the extracellular polymeric substance (EPS). I just breaking by using the dispersion process. I'm breaking the EPS. If you remove the EPS, what will happen? Automatically solubilization has done, and biogas production is increased. So this is my work, and I have published some papers also. This is very important area in this world. In future, if you go to European countries, you can find they are producing more energy from the biogas production, biogas plants, and they have installed many more. They have installed many more biogas plants across the countries. So this is a simple process of uh, producing the biogas from the dairy waste. Thank you.
Thank you for listening. If you have any doubt, please put your doubt in the chat box. I can reply. Uh, I encourage all of you to raise your questions. Thank you. See you again.
Hello everyone. Finally, I would like to take this opportunity to place on record our hearty thanks to our principal, Mr.D.P.Rufus sir, for his inspirable speech. I also extend my thanks to Mr. Raj Kumar sir, Mr. Regin Paulson sir, Mr. Jeromia Raj Kumar sir, our college webinar team, and all the participants for their active participation in this webinar. Also, thank you for our management.